Innovations is one such thing that differentiates between the leaders and the followers. Hello and welcome to Rockcom Infosystems. Raza Muhammad Sheikh, and today we're going to talk about Hadoop, one of the innovations within the data world. So today's session have six takes, and that is discussing the Hadoop by its definitions. So definitions of Hadoop can be found, multiple versions of the definitions of Hadoop are there online. So I picked up one, and then we're going to discuss in detail about that definition. And then we're going to talk about the V model, the data volume, velocity and variety and its value. And then we're going to talk about the key questions that a new innovative systems need to be answered with the challenges that has come across with the business and its organization data and organization systems that they have in presence. And Hadoop history deep dive. And finally, we're going to discuss two things about the difference in the versions that have come into existence over the period of time, and also close the whole discussions with understanding the top 5 distributors. So to begin with, let me read out the definition of Hadoop. What it says is, Hadoop is an open source framework that allows to store and process big data in a distributed environment across clusters of computing using a simple programming model. It is designed to scale up from a single server to thousands of machines, each offering local computation and storage. The definition is definitely good, but it was a full mouth. Let me break it down a bit for you to understand what exactly it means. Firstly, understanding the Hadoop by its name. Where did we get this name from, and what exactly the situation was to pick up this name, or the criteria to pick up this name. The name actually came from a stuffed elephant which was owned by a person called Douglas Cutting sons. Sorry, Douglas Cutting didn't own this elephant, his son actually owned the elephant. So the stuffed yellow elephant was named as Hadoop, and Douglas actually had a criteria to pick up his open source application name, being that it should be simple, straightforward, easy to spell and used nowhere else. So that was the criteria, so he picked up this name as Hadoop from the yellow stuffed elephant. And when we talk about Douglas Cutting, who is this person? Douglas Cutting is the director or was the director of Apache Software Foundation. Wow, I mentioned about the foundation here, which is Apache Software Foundation. What is it? The Apache Software Foundation was founded in 1999, and it is basically a non-profit organization that owns all these open source applications. And Hadoop, being a part of open source community, is also owned by Apache Software Foundation. Now, let me break it down about what do you mean by open source. So when we talk about open source, it means basically that anyone is free to go to Apache Software Foundation website, download it and start using it. So you don't have the license bounded to it. And apart from being open source, it is a framework. So to imagine the framework at the moment, although the Java developers or the people who are familiar with the Java on the coding aspect would clearly understand what exactly the framework means, but just for everyone's benefit, it is a structured application. It has a structurized application that allows to store and process the data. This is the core, yeah? The whole purpose of Hadoop is to store and process the data. Now, when we talk about storing and processing the data, the storing actually was an innovation that Google released in 2003. So Google released a paper called Google File System, GFS, and that basically became a base for Hadoop storage, and that's a core for the existence of Hadoop. Douglas Cutting, who was working on another project, which was a web search application project, got the inspiration from the Google paper release in 2003, and he revisited his whole application, came up with the HDFS, Hadoop Distributed File Systems. In following year, which is 2004, Google again released another paper where it's called about MapReduced processing made data processing simple for the large cluster. So that is how the processing came into picture. Now the whole storage and processing is good, but it is for something, right? It is for data. But Hadoop is not for any data. Hadoop is for the big data. The storage, when we come back to storage, the storage HDFS have by default it stores the data block into 64 MB by default, but the industry standards that goes with is 120 MB per block. So it is not for the small chunk of data, it is for the big chunk of data. So it is for big data. Now we talk about the big data a little bit for you to easily understand what exactly big data is, because there's a lot of the confusion around what is big data. For right now, to understand what exactly big data is, anything that is beyond your organization data. So any data that is not able to cope up with your traditional organization system is to be considered as big data. Fine. Furthermore, it is distributed environment. What does it mean is, you can imagine firstly what exactly distributed environments means. If you are coming from the data warehousing background, imagine this star schema where you have a fact table and this surrounding dimension to it. So if you convert that image, the dimensions as your the servers or the nodes, what you can call it as, where your data is processed, or maybe there's some kind of server that can be used for the processing needs, and those servers can be connected to LAN and WAN. Okay, the fact table being a connector in between. So when you have that kind of environment, right, these multiple servers connected to LAN and WAN, that is called known to be as a cluster. So that is a distributed cluster. In another sense, distributed means that the local storage or the local file system which is centralized and commonly used by the different servers. So the fact table information can be used by the commonly servers. Okay, so just trying to make it simple. Hope that makes sense to all. The distributed environment is all about that. So when we have that kind of environment, there are possibilities that any one of the servers might fail. Okay, so the Hadoop has the software capabilities within itself to cope up with that fault tolerance capability. So it does have that across the clusters of computing. Simple programming model. It is designed for scale up from a single server to thousands of machines. This is very interesting. I'm pretty much sure that you might agree with this, that whenever the project is started, okay, very initial stage, we bother user a lot, actually making sure that what will be the volume of data that would be coming in next 10 years of time, what kind of data volume are you going to deal with, what is your prediction on all those things, putting some kind of assumption. Why do we do that? Because there is a headache to get a proper configured server and get that approved from the procurement upfront, so that we don't face the issues later stage. This is not the case with the Hadoop when we implement it, because Hadoop gives you the capability of scaling up at the later point when there is a need as an occurrence. So initially you can have a small cluster nodes of clusters, and then you can have that cluster scale up and scale down as and how that is required. So that is a flexibility that Hadoop gives you along with the distributed environment. Each offering local computation and storage. I love this concept because if you remember, if you are from the ETL background, which is what I am also from, initially we had that the data was moved towards the calculations. So the ETL was there. So you take the data, moved into the calculation part, did all the calculation transformations and so on and so forth, and then you dumped the data back into the another system or the sales system, whatever it is. So that is what the ETL concept was. But later stage, we moved into ELT, which is basically extraction, loading and transforming the data. So the distributed file system and the map reduce processing data, is the architecture which actually leverage the ELT concept, where your the computation is coming to the data rather than data going to the computations. Hope that is made clear. So moving forward, we're going to talk about the V model. So earlier, if you look at the data volume that used to be dealt with as MBs or GBs, now we are talking about the terabyte and petabyte. To give you an example, Google process almost 24 petabytes of data per day, and 2.5 billion share and trades that are happening in the New York Exchange per day actually, and Facebook process 4.5 billions of likes per day. So this is a huge volume of data that we are dealing with, which is not possible to be addressed by the traditional systems or the RDBMSs. And then when you talk about the velocity of the data, so initially I remember when we used to process the data, it was a batch process, sys -1, okay? And the data was ready by 7 a.m. and 8 o'clock. The users basically start using their reports for analysis purpose. But later on, the demand for periodical data availability came into picture, that the files basically are being made available periodically. So why don't we actually make use of that data which is available? So periodical processing actually came into picture. Then slowly we heard about the concept of near to real time, and then finally in real time. So the velocity of the data which is made available is been discussed, and there is multiple reason for that, because there is automation processes that are faster than the manual, and numerous interconnection systems and exports and transfers have been happening. And finally we're going to talk about the data variety. So initially it was tables and databases. Now we talk about, like, WhatsApp, lot many photos, videos, and then kind of mobile application data, and then you have a lot of like Facebook, the social media, lot many things. Everything, if you look around, is generating the data, the sensors and so on and so forth, and business is basically valuing that, because they have seen a tremendous outcome of ROI if they have effectively using the data. So they value the data, and they wanted this all data to be made available, which otherwise is not mapped with our traditional relational models. So this is the kind of image that I've come up with on the internet. So just want to show that up until here, let's say 2000, the business was focused on just on the business data, okay, and there was no much of automated processes that were involved, no huge computations were involved, and so on and so forth. The computer itself didn't become heart of the system by this time, but the later stage, over the period of time, the computers became heart of the system. You can't, like, I recollect one of the time I wanted to purchase a product and went to the shop, got the product, I had the money and everything, and whatever I was looking for is there, but I wasn't able to purchase, nor this shopkeeper was able to sell that to me. The reason being, the system was down. Okay, so bearing that in as a fact, you can't do the business if the systems are down at the moment. The business realized that. Hence, they are actually trying to catch hold of that application data, which is a huge volume of data, along with growing the business. So along with the combination of both, they are trying to take the leverage that data and take it to a next level for the better decision making. Okay, so going forward, the key questions that need to be answered. So business have two key questions. There might be multiple key questions that have been coming out from the business community, but if you consolidate them, they'll fall either of these two. How can we reliably store large amount of data at a reasonable cost? Because that is really core. You have to have those systems where it is within their budget and within the capability of having to get them so that they can store the data. It shouldn't be otherwise. How can we analyze all the data we have stored? So when we store the data, they also have to analyze this whole thing. So the front end and the back end kind of things. So this was the key questions what innovative system have to be answering, which in this case being Hadoop. Now the timelines that I want to discuss about Hadoop is very quickly going through. We understood that the first non-profit organization that came into existence, which was called as Apache Software Foundation in 1999. What happened at the 1999 is basically two persons, Douglas and Mike, started working on a project called Nudge, which was a web-based application project, and they had some kind of challenges in getting the data, rendering the data in a very quick fashions, and so on and so forth. So that was in 2002, and between 2002 and 2006, we know that there were two papers that were released. That was in 2003, Google released Google file system white paper, as well as it has released MapReduced, made large data processing simple in 2004. So Douglas took this opportunity going through this paper and revisited the whole application. And while he was doing that in 2006, he moved from Apache Software Foundation to Yahoo. And that is where actually he released the first version of Hadoop. And 2008 is where the Nudge was separated. 2006 when he moved from Apache, he took Nudge along with him, and he separated divided Nudge, and that is where the Hadoop was born. And Yahoo actually released this Hadoop back to open source to Apache Software Foundation. So the Hadoop was released back to Apache Software Foundation. Hadoop, started as a distribution, getting into the market. As the first distributor of Hadoop was Cloudera. So 2008, there were kind of noticeable changes that have come into existence. Moving forward, in 2009, Douglas basically moved out of Yahoo again, and he went and joined Cloudera as a chief data architect. 2011, Yahoo actually released a free distributor, open source distributor, which is known as Hortonwork, and also MapR, one of the other distributor that got into existence in 2011. So there were movements, right? There were movements of Douglas moving from Apache Software Foundation to Yahoo in 2006, and 2008 was a core where the Hadoop was made available for the organizations to start using. And if you recollect, this is the year where the big data buzzword was actually been called out throughout, and the Cloudera was the first and only distributor for the Hadoop. And in 2009, Douglas moved from Yahoo to Cloudera as a chief data architect. And 2011, there were two other distributors that came into existence, that being Hortonwork and MapR. Okay, moving forward with the ecosystem timelines. So the base for everything, the innovation, is Google. So 2003, Google file system, 2004, MapReduce made simple, and that is where the Hadoop version 1 was introduced in 2006. 2007, Yahoo basically introduced Peg, which is programming scripting that sits as a wrapper on top of the MapReduce. So MapReduce was difficult, having to get the MapReduce code done, the talent was very difficult. So to overcome that challenge, the Pig was introduced. See, that is how it happens. From the animal, you get the name, and then you keep on getting the animals. The cloud era actually got into existence in 2008 as a only distributor, and Hive again is one of the analytical tool which allows you to write a SQL-like query, which is called as Hive SQL. Hive is a structured query language. Query language, which is same as SQL, and you can write the query and retrieve the data directly from the HDFS as a tabular format. So Pig and Hive actually got graduated in 2010, and Zookeeper actually came into existence in 2011 as well, and Yarn was introduced in 2013. This is a great release, and that's a turning point for Hadoop. And why was Yarn actually introduced? Because in 2012 Yahoo hit a deadlock. Yahoo was not able to scale up his cluster for more than 4,000 servers or nodes. So that is where they have realized that the limitation of Hadoop version 1 was to have no more than 4,000 clusters, and the MapReduce was overstressed by the time we reached that particular number of scaling up that number of nodes within the cluster. So Yahoo spent a lot of money and invested a lot of time to enhance that capability and bring some kind of a new version to Hadoop. So Yarn was introduced, and that actually we're going to discuss about that Yarn capabilities in the next slide. So that actually gives a opportunity for not just to have MapReduce as a data processing engine, but to have new upcoming technologies as a data processing as well. So in 2014, Spark got into existence, which is again a data processing engine based on MapReduce, but it is an in-memory processing. Now coming to the difference between the version 1 of Hadoop, okay, you have common or core, which is the utility that is holding all your jar files and so on and so forth files, and the common and core is where all your Hadoop components. So when I talk about the Hadoop components are MapReduce, HDFS, and common. Okay. All these components access through common, and surrounding these components you have ecosystems. You have Hive, Peg, and Impala, and so on and so forth, whatever comes into existence. So they all access through common. Okay, fine. And then you have HDFS, which is a Hadoop distributed file systems, and it is a redundant reliable storage. It stores data in redundancy, at least for 3 folds. Okay, and the MapReduce. In the version 1, MapReduce played a dual role. It played as cluster resource management as well as data processing. Now what happened in 2002 is the 2 components, whether it's HDFS or common state, is it remained the same. There wasn't any changes in that. But what happened is MapReduce was being dedicated to do only the data processing. So Yarn got into picture and said, man, you are good with the data processing, why don't you just do the data processing, give me the resource cluster management kind of capabilities. And that is where the breakthrough has happened, and the dedicated layer was put in place for managing the resource. And when that happened, the other data processing also was possible within the architecture. So that's a quick glance of the difference between the version 1 and version 2 and on a high level architecture. Now distributors, when we talk about the distributors, Initially we discussed about Hadoop being open source. So it is still an open source, there is no doubt about it. You can go and get your vanilla version downloaded and start using the Hadoop. But when we talk about open source, it opens few doors. Okay, it opens the door for some kind of bugs and issues. Being a software, this is all normal, isn't it? And moreover, it doesn't have lot of other capabilities which is more or less required to become a enterprise fit. So that's the reason the distributors comes into picture. For you to have a quick understanding and grasp of what exactly the benefit might have, organization get with the distributors, you can, go and get the parts for the car from anywhere. Get that all the parts, there is no doubt about it, and assemble it and make your own car, which is possible, there is no doubt about it, but it would be a difficult one. So distributors basically is where you go and get your favorite car so that you can straight away drive on the road. That's what it's all about. So the distributors basically help in Hadoop to get all its components and all its ecosystem in a packet for the easy installation. Not just for that, but it is basically the reliability, because the distributors have spent a lot of time doing a research and getting all those components together. They have the experts, so the reliability of what they have come up with is possible, and moreover the support has been given by the distributors, because they know the system in and out. Easy for them to give us support for the companies or the clients, and they have a complete package, one end-to-end package, rather than getting the vanilla versions of Hadoop, then the ecosystems from here, multiple things, and maintaining it. It is possible easily to go with the distributor. So that's what the distributor is all about. And then finally we're going to talk about the distributors itself. Standard version, the vanilla version of Hadoop, go to Apache Software Foundation, download it and use it, but you have the pain along with the open systems. But if you go with on-premise, which is Cloudera and Hortonworks and Mappa, you get the package deal. You get the ease of using the application, the kind of data governance capability, and so on and so forth. Having said that, there are a lot many distributors, but I'm talking about the top few distributors that are presently in the market. And then when we talk about the the cloud environment, you have obviously Microsoft Azure and the AWS. So this is a quick glance and the introduction to Hadoop. I hope this has made very easy and very explanative. If it's so, please do like or subscribe to us. Thank you very much.